Welcome to the first session of Introduction to Data Management. I am Niveditha from the George Institute and will be delivering this session. I hope at the end of this session, you will be able to appreciate the importance of planning data management for a project, describe the major phases in data management and key activities in each of the phases, describe roles and responsibilities of the project team with respect to data management. So towards these objectives, I'll be discussing about what are data, the purpose of data, data management, data cycle, who does what, and data management in practice. So let's get started. So what are data? Data is nothing but collection of facts. But why do we collect data? So data as such does not make much sense until we convert it into an information. For the data to become an information, it should have context, structure, and should be analyzable. And this information becomes a tool for decision making, let it be a policy or practice, and that in this information should be credible and relevant. Relevance totally depends upon what question we ask and what data we collect to answer the question. However, credibility is more about the processes we use for collecting, for managing data, and for documenting all these steps. So you can see the purpose of data is ultimately for decision making, and hence it's important for us to think well ahead what could be the threats in establishing this credibility. So this is something which you could reflect upon after the end of this session with respect to the project which you are involved in. So what are the different types of data? Commonly for a researcher, it's data from research participants. These could come from responses to questionnaires, could include personal identifiers, hospital data with lab-related information, or derived data which can be from any of the above. They also would include administrative data such as dates and the person collecting the data, and the context related to the data such as location, time, and conditions from where the data was collected from the research participants. Irrespective of these, all the data have some attributes. When we say data attributes, these are the properties. The format could be very varied. They could be text, they could be numbers, they could be audio files, video files, they could be a mixture of everything. The speed with which the data is accruing is extremely important. The languages, the source, each of the data can come from very different sources. And also the quality from where the data comes in could be varied. And the complexity in terms of analyzability and interpretability could also be varied. So in a typical study, data could have various attributes which all will impact the way you plan and manage data in your project. So what is data management? Once you know what to collect, what data to collect, then you set up collecting the data from people. But irrespective of how you collect the data, it should be converted into electronic format, that is a collation, and for which you have electronic or computer systems, which I will be discussing in the next slide. Once you collect and collate, you need to confirm. Confirmation is a process where you check if the data is right in terms of range, logic, as well as biological plausibility. So post collection, collation, and confirmation, you're ready to analyze. However, most of the time, the data will need some processing before it leads to analysis. With the advent of electronic data capture systems, your collection, collation, and confirmation becomes one step, following which you process and analyze the data. So what is data management? Everything you do before analysis is data management. So use of computer systems are vital, and that's the reason so why do we need them? we need computer systems to organize the collection of structured information or data to store them electronically. A typical example of a database is an Excel sheet. However, rarely we use Excel sheets for research purposes, and that's because they don't fulfill all the properties of a data capture system. Ideally, data capture systems should have user control and security. It should allow multiple users to enter the data. It should be able to support complex structures and also hold large data. It should also be able to track changes in terms of time and person. So typically databases are represented in this icon, which holds the data in a structured way so that they are analyzable. So far we have seen what is data, what are data, data management, and databases. Now let's move on to the next section, which is data cycle. So every project generates data. So you start with a plan, then you execute it, where you create the data, and then you analyze and disseminate, and then you archive and share so that it's ready for reuse, which can generate further research questions, and you start again the cycle. So in planning, your first step is to know what to collect. Next, to understand what are the attributes of the data which will impact the data management, and you plan and you document the plan, which is the data management plan. You also document something called metadata. Metadata is nothing but data about data, which gives context to the data which you have collected. During the creation or the stage where you collect and collate the data, it's important to follow some standard conventions, be it naming the files, folder management, version control, how do you maintain your metadata, and ensure you have enough measures for ensuring data security. For following collection, you want to disseminate your findings after analysis, where you first curate the data, which is data processing, analyze the data, and then disseminate. Even at this during stage, there are many people involved, and there are various stages which happen within the analysis. So you should have a version control. You should be able to know which softwares to use, and also have a way to collaborate between teams and be able to store the data in a secure way. So we'll be looking at a separate session which could about practices which will ensure data security. After dissemination, the next step is to archive the data. Archival is needed because there are certain policies and regulations which require the data generated from research data to be stored for a certain period. So archival is like a library where you keep everything in a place, but you are able to take it when you need it. And typically, you will also want to share your data for reuse. And this is the reason we want people to be aware about sharing policies, data sharing policies, which will be covered in another session. And this next aspect is about the data should be fit for purpose. And that's the reason they should be reproducible. Reproducible in the sense, once you collect the data and you take it out, it's the raw data. After the raw data is processed, it becomes the processed data just before the analysis. And then you use the data to produce the results. The steps from raw data to the processed data to analysis of the results should be reproducible. So this is a brief summary about data cycle: planning, creating, distribute, and reuse. So how does data management happen in practice? So planning. During the planning stage, the first step is to design the questionnaire, for which we need to know what to collect. We'll be having a separate session on questionnaire development. The next step is to be able to convert the data which we collect into electronic format. And that's where we need the databases. So to convert the questionnaire into the format which we need, needs some specifications, and that's what we call the database specification. And this is a stage where researchers and the data managers collaborate, and then the programmers are designing the database. However, after that, there needs to be tested or validated so that we know the database functions the way it is intended to function. We also need to do an important step where researchers play a role of the user acceptance testing to see if it is fit to be used in the field or where it needs to be implemented actually. So the entire step of activity from questionnaire development to database specification, designing and validation becomes the planning stage. The next stage is about conduct, where we collect the data. But before we collect, before moving from the staging, the designing stage of the database to actually deployment is when you give access to the real users and also you have trained them using the manual data entry. There will be a need for database maintenance. That's because there could be some mid-study updates. Mid-study updates typically comes due to poor questionnaire development, or sometimes which could be unpredictable reasons or unexpected reasons. However, mid-study updates should be kept to a minimal, and that's the reason questionnaire development should be very thoughtfully done. Frequent mid-study updates is not encouraged. The other aspect about maintenance is about frequent backups to prevent data loss. And there could be some programming errors. And if we don't do the database validation well, there might be some bugs which needs to be fixed. The next thing about conduct will be about confirming the data. This could be by use of query management systems within the database, which will flag erroneous data. Or it could be also that the data is taken out of the database and you set up routines, data cleaning routines external to the database. So typically collection and confirmation happens around the same time, parallelly. Once the data collection is over, you set up for analysis. But before the analysis, you lock the database so that no further changes happen. And before you lock the database, you do one final cleaning and then you lock. And it goes to the analysis, for analysis. And then you archive the database along with the data and the different versions of the data such as raw data, processed data, and the final analyzed data. And then the data should be fit for sharing and you have all the documents in place for data sharing. And these are the key activities during the closing stage. So as you can see, there are different people who might be involved and there are various roles and responsibilities which needs to be clear for a researcher. So the first is a database programmer. So this person typically designs the database and does the programming. These are typically these are typically software engineers or software engineers who develop this. Next is the database administrator who typically manage user access and rights and are also responsible for backup. Data managers are those who are linked between the programmers and the researchers. They develop and maintain the data management plan and also sometimes would be responsible for data review. An information technologist, IT expert, who will be responsible for maintenance of the hardware which collects and maintain and stores the data, and as well as the server maintenance. If you have a paper-based data collection, then you have data entry operators who enter the data from the paper into the database. When you directly use the electronic data capture system, and typically research associates and field associates are responsible for that. Next, we have the statisticians who are responsible for processing and analysis. And then ultimately, we have the researcher who has to approve the key documents and ensure resources for all these activities. So as you can see, there are various roles and responsibilities, everything related to data management. So how does this happen in practice? Typically, one person or a couple of people can wear multiple hats. You may not have different individuals for different of the various roles. Now we see that how do groups work. So we have this investigator, we have a project team, we have data managers and programmers, and the statistician. While the investigators are approving tools, ensure that the critical data are collected, ensure budget, time, and manpower are there, the project team is typically responsible for designing tools, develop the specification document, develop the data entry manuals, and also do the quality control. Data managers are designing and validating the database, maintain the develop and maintain the data management plan, manage rights, train the team to use the database. Sometimes are responsible for data quality and of course for the data security. Statisticians ensure that there is a link between research question, the tools which are designed for collecting the data, and the analysis plan. So this link is extremely important so that you know that your data will answer the question using the appropriate analytic method. Sometimes statisticians or data scientists are also responsible for doing statistical monitoring during the data collection time to identify problems such as fraud or fabrication of data. Now, how should it actually work in practice? Each one, instead of working in silos, should be interacting with each other. There should be communication between the investigator and the statistician at the planning stage to ensure that you are collecting the correct data and are in the analyzable format. The statistician and the data manager should be in communication so that they know the data which comes out of the database can be analyzed without too much of data curation. The project team should be in touch with the data manager, so that they specify the database to reflect the data collection tools, do the user acceptance testing, and the investigator and the project team will be in communication so that they ensure the data quality is happening the way as per plan, and to also highlight the challenges which might happen as the project progresses. So it is important to formulate a team, define the roles and responsibilities, and to be in constant communication with each other for a successful data management. So coming to the summary, it's extremely important that we have to establish, as researchers, we are responsible for ensuring that the information which comes out after the data is trustworthy. The importance of data management also is important because it establishes the credibility of not only the the researcher, as well as the organization from where the research is being conducted. It's also ethical responsibility that we generate data which will be responsible for relevant change in practice. Having good data management practices and a data management plan is also a regulatory requirement, typically in clinical trials. Having a good, robust data management systems and teams is important for research efficiency and thereby could be cost saving. And finally, data should be fit for purpose and hence they should be reusable, as well as you should have data sharing policies in place. So this is a brief summary about why it is important to have data management plan and to think about data management even before the project starts. So you should have a multidisciplinary team, you should work as a team, you should have the time, adequate time, and not rush through during the planning stage. You should have the adequate budget to support these to ensure ultimately credibility of your data and the subsequent information. So I hope this meets the I hope after listening to this session, you're able to appreciate the importance of data management, describe the roles and responsibility in data management, describe the major phases and the key activities in each of the phase.